And good evening. We're back here with you talking about some severe weather coming up here in Virginia. And this is Tuesday, April the 4th. And I'm joined again by my co-host, Andrew Smith, who's going to take things away here in just a minute. I'm working some technical issues trying to get our guest panelist on here. I'll continue to work that and kind of turn things over to Andrew here, since he's the main one that's located in the path of this, being there in the Richmond area. So I'll kind of sign off and work on some other things here real quick. And Andrew, I'll let you talk for a couple minutes.
All right, thank you, Chris. Yeah, this is a little different setup than we're used to seeing here in Virginia this time of year. We're looking at a kind of an early morning setup for severe weather coming through, almost like a rush hour time frame. Usually, Virginia, we're used to dealing with storms in the afternoon heating, 3 o'clock hour, and that sort of fashion. But there's a very strong area of low pressure that's going to be working its way up through the Mississippi Valley, heading up to the spine of the Appalachians. And with it, it's bringing a ton of wind shear in the environment, some instability from the Gulf of Mexico, even drawing it off the Atlantic Ocean. So it's a timing thing, really. Earlier in the week, this thing looked like it was going to be coming through during the prime of the heating hours. And as the event's gotten closer and closer, the model's gotten a better grasp of it. It's kind of pushed it to coming through in the middle of the night. So despite the lack of daytime heating, this thing still looks like it could pack a punch. So I've been looking at the models here this afternoon, just trying to get a grasp of where it's standing now. And I've been using a 3K NAM. Let me see if I can get the screen share going here. Alrighty. So what we're looking at here is surface-based CAPE at about 5 o'clock in the morning. Kind of an odd time to be looking at the models, but that's what we're dealing with here. So you can see down here in southern North Carolina towards the Fayetteville region, I mean, they have CAPE values upwards of 2,500, which for overnight on the East Coast in April is unusually high. Up here towards Richmond, it's the instability hasn't quite made its way up. We jump forward to about the 8 o'clock time frame. You see the CAPE starts pushing its way in. So the instability from the south is working its way up as the cold front. You can kind of see it here with the edge here with the CAPE drop off starts pushing in. And so aligned with that, we have shear being pushed from the front upwards of 50, 60 knots. Back where the front's really coming through, we're looking at shear upwards of 100 knots on the 0 to 6 scale. Storm relative helicity also is off the charts. These are numbers that if you're chasing out in the Great Plains in the summertime, these are numbers you'd love to see. And this is kind of typical of when you get winter storms on the east in the wintertime. You can get these kind of values, but there's no instability to feed off that. So now we finally have some instability to feed off of, and it's going to interact with this wind shear and more than likely produce severe storms in the morning time, anywhere from Richmond south. Richmond probably going to be the northern end of the higher end severe. And as you drop down in North Carolina, where the instability is going to be around a little longer and not as contaminated, I guess you could say, from the southerly flow of the moisture from any ongoing convection to the south. I want to look at the supercell composite, which kind of combines all the factors of wind shear, CAPE, and things of that nature to give an idea of where the models predict to see supercells forming. And I'll jump back here again to 5 o'clock in the morning. Again, you can see down here in southern North Carolina, it's looking very high, and that's in response to that higher CAPE value that's down there. And as we move into the morning rush hour throughout the eastern portion of Virginia and North Carolina, you can see that it's spreading its way northward into just east of the Richmond area and down into the Tidewater region, Greenville, North Carolina, Wilmington, New Bern, those areas. Another thing we like to look at sometimes just to kind of see if it's picking up on anything is the significant tornado parameter, or SIGTOR, as we like to call it. And with this, when we start seeing bullseyes, that's usually things to get you concerned, because bullseyes and SIGTOR are usually a good indication that things are coming together to potentially produce not only tornadoes, but even strong tornadoes. And this is, again, looking back at the 5 o'clock hour, southern North Carolina, pushing 5, which is on the higher end. The scale goes up to about 9 or 10, and these kind of numbers are safe to say high for the East Coast and high for this time of year, especially to be 5 o'clock in the morning. And as we move forward into the 8 o'clock hour, you can see that it's pushing east. So the stronger parameters again down in North Carolina, but we can see here into Virginia, east of Richmond, down in the Tidewater region, it's also bumping up into the 3 to 4 category. And by about 11 a.m., this stuff's pretty much pushing off the coast. And what lingering effects may be leaving Hampton Roads area, but that'd be about it. So again, a very unusual setup with early morning storms coming in right at rush hour, worst possible timing, trying to get to work, trying to get the kids on the bus, things like that. So it's going to present a challenge on Thursday morning. I know, Chris, out your way, it's going to be pretty much overnight. Not going to, you'll probably see some good storms out there, but nighttime, not really a good time to be out chasing, especially in the mountains. With limited visibility you already have, you're losing to the terrain. So,
right. Yeah, that's the fallacy of these systems coming through in the middle of the night. I have to throw out an apology to folks that John Boyer and I have been working on technical difficulties, and we just for some reason can't seem to get him on the Hangout. He's not seeing the invitation, so we may have to try him again. Which is a disappointment. I was looking for to get his inputs on this. Yeah, as far as the kind of overall setup and what we've been looking at, of course, what a lot of times will cue us in to what's going on is to pay attention to the upcoming SPC outlooks. And here you have the SPC outlook for this. This is the day 2. This is tomorrow, on Wednesday, and you can see it's pretty impressive over here. If you got the scale, if you're not familiar with the scale, it's general thunderstorms and then level 1, 2, 3, and 4 as you go up. And here in the western part of the state, we're in a slight risk, or that's level 2 actually of the severe risk, which looks pretty impressive with the enhanced back here. Problem is, as Andrew pointed out, it's all coming through overnight. And just to give you an idea of how that kind of balances, if we move this forward to Thursday, now you can see that here's where things shift. And these are all starting, I believe they start at midnight, I believe, for these outlooks, and move forward. I'd have to look at the fine print here. But
yeah, I'll look that up for you.
But this area over here is the level 3, or the enhanced risk that the Storm Prediction Center has for day 3. Now they may modify that tomorrow when they put out the day 2s to cover Thursday. But as Andrew's been talking, the difficulty is when this is coming through. It's tough for chasing, but also it's tough for people, because when these storms come through with potential rotation, as we'll talk a little bit more about, the high winds, potential for even some tornadoes, and they come through at night, that's very difficult. So that's something we all have to keep in mind.
Yeah, Chris, they're valid from 8 a.m. to 8 a.m. Day to day. So that's, I wouldn't be surprised if tomorrow that gets shifted just a hair more eastward, just given how it seems the system continues to speed up and push itself out quicker compared to earlier.
Right. And just looking, I was looking at earlier today at some of the upper level parameters, the forecasts, and the trend does seem to be to push the activity off the coast, even though the surface front itself will come through later in the day. The dynamics that are forcing the instability and the shear that's going to cause the rotation is coming through earlier. And that's a real concern, I think, as you mentioned, Andrew, for people, not only the morning commute for commuters, that whether it be heavy rain and potential, strong and severe thunderstorms, but school children as well. And that's, and I've got grandchildren over there on, just east of Richmond that, of course, I could be concerned about them getting on bus and heading out with severe thunderstorm warnings or possibly even tornado warnings on Thursday morning. So that's a concern for most folks.
Yeah, the last time I can think of severe weather like this rolling through in the wee early hours was, I think, back in 2003, back shortly after Hurricane Isabel moved through. About a few days after that moved through, a line of severe weather came through and actually produced a few tornadoes on the north side of Richmond, and I think 5 or 6 o'clock in the morning. So it's not unprecedented around here for it to happen, but with with my memory being 2003 being the most recent, 14 years, you can tell it's not that common of occurrence to see this kind of a setup come through here, at least at this time of day.
Right, and I think one thing that's worth talking about here, we'll talk about the chasing aspect of this in a little bit, but one thing that's worth talking about for folks is to make sure that you can get warnings in the middle of the night when you're asleep.
Mm-hmm. Mm-hmm.
And I know myself, of course, I have a weather radio, but I also use apps. There's a couple of local apps. I use one called Weather Radio, which is an app that you can find on the App Store. Mm-hmm. And you can tailor that to send out alerts for any kind of warnings. There's whatever warnings the National Weather Service puts out. You can pick all or none or some in between. So, and that'll come out, if that comes, a severe thunderstorm warning or a tornado warning comes out in the middle of the night in your location, that will sound an alert, just like a NOAA weather radio will. I know there are other apps. There are probably some local apps there in Richmond, maybe some of the other media outlets have them.
Yeah, I know Channel 12 does, Channel 6 does, I would assume Channel 8 does. But yeah, they're all very useful things and important things to have, especially in setups like this, especially out your way when it really is going to be an overnight thing. Here in Richmond, we're looking more towards daylight where more people will be up and about. But further west you go in Virginia, Wednesday night into Thursday morning, that's when you, like you said, you need to have those alerts to be able to get them to you and have some way to do it, whether it's your phone or weather radio or what have you.
Right, and that's why it's important to key in on these events and look ahead at them, because when they come through at generally, I won't say unexpected times at night, but unusual times of the evening, most folks aren't paying attention to the weather once they kind of go in and close the doors and close the windows for the night. So you want to encourage people to make sure that you have multiple ways of getting warnings, the weather apps, weather radio, checking the media, and having a plan in place before it happens. And that would be important as well.
Agreed.
So, well, as far as the chasing aspects of this, first and foremost, unless there's extenuating circumstances, I don't chase at night.
No.
I have been known to go out and find a vantage point and just watch a thunderstorm rumble through, say somewhere where I could safely watch it, just to watch the lightning and stuff. But to actually get out and chase this particular setup, when you have the potential for rotating storms, and we can show some of those graphics here in a little bit, at night, especially here in Virginia, where the road system is not really conducive to A, getting out of the way of the storm, and B, being able to see the storm. And then, of course, at night, you're dependent on lightning flashes, and it's just something I don't generally do. Now, that's it's not to say that there are probably or could likely be storm spotters out if the National Weather Service actually puts out a call for spotters. That's a possibility. But those are folks that go to a known place, maybe at the end of their driveway or the edge of a field near their house, and watch for something. But for me to go out and do that, I just typically don't do that.
No, it's especially early in the morning. It's a little different when you follow a storm into the night and you've been chasing all day and you're good to go. But when you have no bearings whatsoever, when it's been dark the whole time, and like you said, all you're using is lightning flashes to get a view of the storm. Seeing a storm with lightning flashes is barely good enough when you're in the plains and you have great visibility and no trees. But like you said, around here in Virginia, when you're fighting bad terrain, bad roads, and trees, you don't even know where your vantage points are to even see the storm at that point, much less try to see the storm when the lightning's illuminating it. So, in the wee hours of the morning, it's not a smart thing to be out there trying to chase these things and see them. And like you said, with a lot of rotation that we're seeing on some of the models, it's dangerous to be out there in those kind of conditions.
Exactly. And I think too many people, and I've been known to point this out to some of the students on the Hokie storm chases we've been out to, but too many people rely on these things to tell them what's going on. And if you have a radar app of any sort, I use Radar Scope. I know Andrew probably does. There's other equally good applications. Problem is there's data latency. They aren't real time. And there can be 3 or 4 or 5 minutes between updates, and a lot can happen, as Andrew knows, on a developing active dangerous storm in 3 or 4 minutes. And if you can't see that, you can't rely on your radar application to keep you out of trouble.
No, I mean, the National Weather Service radar only runs every 5 minutes during rainy conditions. So, you know, when you're trying to go to a storm, yeah, sure, that's great because you're approaching a storm. But when you're on a storm, you throw the radar out the window. You're visually looking at it at that point. You know, radar is not going to tell you anything your eyes aren't seeing. You know, you're just looking for a hook on the radar, but you're looking up and you're either seeing the tornado or you're seeing nothing. You know, that's what's more important in that near storm environment than whatever radar is going to tell you.
Oh, exactly. So, you know, I always, you know, emphasize the mark one eyeball when you're out chasing. You know, pay attention to what's going on outside the vehicle or outside of where you are, and don't rely on these things too much. You know, sometimes navigation, it can help, but you know, I'd rather rely on experience and knowledge rather than, you know, just, you know, trusting electronics to give you something exactly where you are. So,
and yeah, fully agree.
As an example of what we were talking about with some of the graphics, let me share this screen that I've got here. Let me put this up. Come on, you can do it. Computer's being slow. For some reason, it's not going to let me do it. All right, let me try it again.
Are you pulling up the helicity swaths?
Yeah, and okay. There we go. Yeah, it was just looking at me. It wasn't doing anything. So this is this morning's run, the 12Z run of one of the WRF runs, the weather research model runs that are relatively short range. And this is at 0Z, so this would be 8 p.m. tomorrow evening, Wednesday evening. And these are helicity swaths, updraft helicity swaths. And these are just kind of an indication of where rotating updrafts might happen. You can see out in the Midwest here, and then down over Kentucky, Tennessee, and down to the south, there's a bunch of swaths moving from southwest to northeast. But let me run this forward just hour by hour so you can kind of see how that works here coming into Virginia. And now we're at 11 o'clock. Here's midnight. And then we get into the post-midnight hours. Here's a couple of swaths starting to enter southwest Virginia here. This is not too far from Roanoke, where I am. And this would be at 3 a.m. There's some stuff that's coming in out of North Carolina into southeastern Virginia at the same time. We run this up even further, and you can see they keep going. And this is all at night. This is without the heating of the sun. This is just pure atmospheric dynamics. And they'll just run it up further. And it stops at 12Z, which is 8 a.m. on Thursday, this particular model run. But that just gives you an idea. There are other models too. I don't know. Do you have one that you wanted to bring up there, Andrew?
Yeah, I was running the 3K NAM. Let me pull up the same thing you were looking at. Let me get my screen share. Okay. Yeah, so the 3K NAM is kind of similar, you know, especially out to the west. You're picking up on a couple of intense cells in the Ohio Valley region. Not as impressive in the south as it was on the WRF model, but and this one only runs every 3 hours, unfortunately, but I can go a little bit further out. So this right here is about 5 in the morning, and like you said, you can start seeing it coming into the Roanoke, right along the Blue Ridge, Roanoke Valley region. Moving forward, you can just see scattered little swaths all over the place. So I guess the good news, if you'll take it, is there's nothing really defined looking on here to indicate that there's going to be a super organized cell potential. But the fact that there's that much rotation tells you that there is going to be rotating storms out there, you know, and if one can just happen to hit a boundary or anything that's out there that the models can't pick up, you know, it doesn't take much to create a quick little spin up. So even the weak little rotating storms can come to life very briefly and produce brief tornadoes. And it doesn't take much of a tornado to be a bad tornado, as we saw in Waverly last year with an EF0 causing death. So
exactly, and I think there have actually been some videos here recently out from the south and from out west where, you know, what seems to be a small tornado is doing things like flipping cars over and turning RVs over. And so it doesn't have to be much. And it could also be straight line winds too. These cells could bring some strong 60, 70 mile an hour gusts, and that can do a fair amount of damage as well.
Yeah, if these storms can tap into some of the upper level winds up there, if the cloud tops get high enough and the downdrafts pull down some of those winds, there could be some very damaging straight line winds. When you're dealing with 80 knot winds aloft, that if that gets drugged down to the surface, that's a powerful wind gust.
Exactly, and I wouldn't be surprised. I haven't looked at the temperatures as much, but I wouldn't be surprised there wouldn't be some large hail with some of those bigger downdrafts, just because of the strength, the fact that the updrafts were rotating and the strength of the winds up there.
Yeah, and I'd be a little more concerned about hail to the south, where there is going to be increased instability.
Right.
But yeah, anywhere there's going to be a storm with supercell characteristics, you'll have to be on the lookout for hail. But to pinpoint a worse location for that, I'd definitely be looking south towards the North Carolina border, down towards like the Greenville, eastern North Carolina region.
Right. Now, in terms of your side of the state, what and the fact that things are going to be happening right around the morning rush, what are your plans? Are you going to try to get out and do any chasing?
Yeah, I think I'll have to look at what the models are doing tomorrow. If they start pushing the storm so fast that it's coming through at 5 in the morning, there's nothing I can do. At that point, I'd be probably chasing these storms, even trying to get to a vantage point on one of the peninsulas further to the east to even see them. So it's just going to depend on what the models do and how the system performs. I'd like to get out there if I can. I'm out there at 8 o'clock and done by 10 o'clock. It's not a bad morning. But I think my window for chasing is going to be to the east. I don't think there's going to be any likelihood that I'd start off going west unless this thing just suddenly puts on the brakes and slows down. So I'd probably look to go to either the middle peninsula or the northern neck, out towards the Matthews area, Gloucester, to going northwest from there. Because as I discussed in our last discussion, the terrain east of here is you can get some nice good open farmlands and vistas like that, but you're dealing with the rivers, and there's only about 5 or 6 bridges that will get you from one peninsula to the other. So you've got to plan your route accordingly to how you need to hop across the rivers once you start getting out there.
Exactly, and that's something about chasing I think a lot of people don't realize, is that you have to think 4-dimensionally. X, Y, and Z is fine, be in the right location, but you have to be there in the right time. And in that, sometimes the right time means you need to be thinking ahead of the storm. Like if the storm is moving southeast or southwest to northeast, a lot of times these supercells, given the right dynamics, can split, and the right-hand split will turn right and head due east. You need to be prepared for that. Yeah. So if there are no roads to get in that direction to get out of the way, then you need to think twice about that storm. So yeah, I can see it's pretty tough to chase over that way.
And I can't tell you how many times I've been on a storm it's gone right through Richmond, and it's just tracked right along the 360 corridor, leaving northeast of town, and it's either been just west of the corridor or on it. And like you said, if storms get that punch of energy and they turn right, the last place I want to be is on 360 with the storm that's turning right with no escape route. So it's weird thinking that I'm sitting in Mechanicsville watching a storm, and then I'm thinking, okay, I need to go to West Point via 64 to get in front of this storm. There's just no other good way around, at least to make time. There's plenty of back roads in between there, but you're not going to make time on those.
Right. And another good point there along with that, which I was going to mention earlier and forgot, was last I looked doing some forecast soundings, these storms, at least in the morning, that Thursday morning, are going to be traveling. They're going to be whistling along again. I think, I was thinking it's like 40 to 50 knots, I believe, storm speeds.
I'm pulling up. Maybe it's not going to let me pull it up.
That's what I remember, unless it's changed, and then that even adds more, because you have to add longer lead time if you're trying to get in front of it. You can't stay and watch very long.
Yeah, and sometimes people, I think, make the mistake of, oh, well, the storm's here, so I can be there in 15 minutes and I'll be there. Well, no, that storm's moving too. Like, it's not just sitting there stationary. You got to beat it and get in front of it, or meet it and then get in front of it. And
right.
And that's the chess game we play all the time.
Yeah, and also a lot of times in these very dynamic environments, the storm is not only moving, it's growing. So the vector of between where it's growing, where it's moving, will make it change and maybe even accelerate. And you get somewhere and you think you might have 5 minutes lead time. You don't. You're right under it.
Right. Yeah. And that's where you got to have your eye to, look around you and see where you start seeing new rain shafts or potential hail shafts coming out of a storm, and realize that you're in an area where there may be a new cell developing, and you need to get yourself to a better position so you're not going to get overtaken and hammered with hail or high winds or anything like that.
Right.
Yeah, I'm having, for some reason, Pivotal Weather just crapped out on me trying to pull up a sounding. So if I can get one to come up here.
Let's see what I can do here, if I can pull up anything. Let's see, let's go here.
Here we are. So this is valid 12Z. Yeah, we're looking at 57 knots storm motion. So they're going to be trucking along.
It's about 65 miles an hour for those of you that aren't familiar with knots. So that's, if you're doing 65 on the interstate, the storm's keeping up with you if you're parallel to it. So,
so like I said, the back roads become very much a non-option for chasing these kind of things. You've got to stay on the main highways where you can make speed, and with the motion of these being kind of a south-southwest or north-northeast, it's even trickier because, like I said, once you start getting east of Richmond, your roads are heading southeast. They're all oriented southeast along the peninsulas, with your occasional northeast across the river. So it really becomes a game trying to keep up with these things.
And Lord help you if one of those bridges is blocked for some reason.
Oh yeah, they got drawbridges in West Point now. Knock on wood, I've never seen one open going through there, but that would be my luck that if I try to go through there tomorrow morning, it's going to be sitting there open.
Right. So I think it'll be interesting on Thursday morning. Well, we'll have to watch how things develop in the models tomorrow, and watch how the local weather service office there in Wakefield, and then of course the Storm Prediction Center who are the one that actually puts out the watches, and Wakefield would be in your area the one that puts out warnings.
Right.
But to see how they develop, what they look for, and then early in the mornings, I know school administrators and parents are going to want to know, about the weather and what's going to happen. So I think it'll behoove people to pay close attention over that part of the state about that early morning commute. And of course, over here in my direction, closer to Roanoke in the mountains, it's the middle of the night thing. In fact, I had a message exchange this afternoon with Brent Watts here at Channel 7 in Roanoke. And I was asking him, I kind of teasingly asked him if he was going to pull an all-nighter tomorrow night. He said, yeah, probably. Because when there's severe weather, they just can't leave. They've got to be there to report on it. And so he may pull in one of the other meteorologists. And, and like I told him, if there's a storm and I've got a couple of vantage points within maybe a mile or two of my house that I'm very familiar with. I know how to get there. I know the back roads. If there's a storm that's visible that it may come through is at 1, 2 in the morning, I may be awake anyway, paying attention to it. So
if the rumbles of thunder wake you up, why not?
Exactly. So I'm sure I'll have this next to my bed watching radar as well as listening for alerts. So I might go out and look at a storm, but I certainly won't go chase it.
Yeah. If this setup had been any other time of the day, if this was coming through at 4 o'clock in the afternoon, this would be a gangbuster setup. This would be, probably one of the top setups of at least springtime. Can't say all year yet because we don't know what's coming down the road. But, these are the kind of systems that typically bring the bigger severe weather outbreaks here, because they have all the dynamics that, usually around here we're missing something, whether it's, the higher shear or the higher cape or just something along those lines. This kind of has it all, but unfortunately this one just doesn't have the timing, right?
Yeah, I guess for normal people that would be, fortunately it doesn't, but for us chasers it's unfortunate.
Yeah,
right.
Well, yeah.
So, all right, anything else? I was trying to think if there's anything else that we need to cover or talk about this particular setup.
I guess the only other thing to talk about is, I think you mentioned right before we came on air, just talking about how convection to the south could play a role in actually dampening this event for us, because that's something that happens quite often in the wintertime when we're dealing with winter storms. When they're dealing with that precip swath is going to start kind of coming across the region before the storm redevelops and heads up the East Coast. When your area low pressure is going across the Gulf, a lot of times you get a huge convection shield down there, and that actually robs moisture from shooting up the East Coast and getting that early snow shield across Virginia and North Carolina. And that's, you had mentioned earlier, that's something to potentially look out for here.
Yeah, I did see that in a couple of the forecast discussions I read. I really didn't pour through the models looking for that setup, but that was a concern that obviously moisture from specifically Gulf of Mexico moisture is
Hmm.
where the juice comes from to really fire the storms in our area here. And if a big convective complex slides across, say, the Georgia, South Carolina area south of here, it interrupts that flow, as you said. And
Hmm.
so the moisture wouldn't be high. The dew points up here wouldn't get as high. The moisture wouldn't be as good, and there would be less instability. So we'll see. And again, the models are coming more and more in focus as we get closer. So we'll kind of watch how the models handle that. But what we don't have to deal with this time is what we as we did last week was the wedge.
Hmm.
There's really not going to be a strong wedge in place. So scouring that out is not going to be a big deal this time.
No, just looking real quick at the 3K NAM, looking at the temperatures and dew points for this is 5 o'clock in the morning. Its temperatures are going to be right around the 60-degree, low 60s around Richmond, uh, going into the mid 60s as you push yourself down to North Carolina. Or excuse me, that was dew points. Temperatures are going to be in the mid 60s around Richmond, pushing into the 70s in North Carolina, with dew points not far on their heels. In the mid 60s. So that's juicy air for this time of year and this kind of setup. And like I said, if the sun was out cooking that, it'd be insane. But that's still energy that these storms can feed off of. You don't need the sun out there for a storm to survive. So
Exactly, and especially when you've got some upper level lift, and there are some indications out ahead of this front and this trough that's coming through. There'll be a couple of little lobes of what's known as vorticity, which is a little bit spin in the atmosphere that'll help pull the air up a little bit,
mhm.
and that can add into this. And the other part of that, having dew point and temperature is very close together. You mentioned like 60s dew points, 70s temperatures. What that generally translates into is a low ceiling.
Mhm.
What we call what's known as a lifted condensation level. That's basically the cloud base. And the closer that is to the ground, the easier it is to get spin ups and tornadoes. That's something else to watch in those areas.
Yeah, we're looking at numbers around 100 meters there. So this is what we call the scud monsters. The ground scrapers that even if you have a vantage point, you're probably still not going to see the bottom of that cloud deck because it's going to be so close to the ground. So that's a good point. Visibility is low cloud decks. If there is something that's going to spin up, it's probably not going to look like your traditional tornado because you're not going to be able to see a whole lot of it.
Right, and hence another reason why I'm not wild about chasing at night.
Yeah, low cloud heights and nighttime, and that's just bad.
Yeah, you're asking for trouble there. So,
very much so.
all righty. Well, I'm sorry that we couldn't get John on this time. We'll try to fix that problem. I had him on a hangout back in I think it was January, and everything worked good. But I don't know why we couldn't get him on this time. We'll figure that out because we'd love to get his viewpoints on these kind of things over in your neck of the woods there, Andrew.
Yeah.
Any last words or things you want to leave folks with?
Just keep an eye out. Keep your ears open to the local media. This is still over 24 hours out, so a lot can change. It can either speed up or slow down. Either way, it's going to be strong storms moving through the region, and the time of day I don't think is really going to matter in terms of the strength of the storms given the nature of the system. Obviously the time of the day is going to make an impact on whether I get out there and chase this or not, but don't think that because the storm is moving faster or slower or because it's coming through at night that you can let your guard down. This is these kind of setups this is what Dixie Alley is famous for, with a lot of their large tornado outbreaks happening at night and catching people while they're asleep. So not that we're looking at a Dixie Alley style outbreak here, but it's the nighttime storms they can sneak up on you and cause trouble.
Exactly, and as we said before, you don't really need a tornado to cause that kind of damage. You can get straight line winds, and of course the other thing we haven't mentioned is a lot of these storms are going to come through with blinding heavy rain.
Oh yeah,
and coming through in the rush hour. I mean, I think everybody can imagine what that might do to rush hour as well.
People can't drive around here when it's sunny, so
Yeah, I hear you. So. All right, well, we'll reconvene this next time a setup comes through. It looks like we're going to be quiet for a while after this settles out, for at least maybe the next week to 10 days. I haven't looked any further than that, so it may be a while before we're back on here, but we'll do this again, and we'll try to make sure that our guest panelists can get on next time.
Yeah, technical difficulties. You can't do much about them.
Exactly. All right, Andrew, thanks a lot, and thanks for everybody out there for watching. Talk to you later.
Take it easy, everybody.